So an infinite series, and this is, or does anyone know what that letter is called in the Greek alphabet?
Epsilon.
Nope. Epsilon. Those are all Greek letters, but begins with an S.
Sigma.
Sigma, there we go. You actually do this a tiny bit in algebra 2, but didn't you guys do algebra 2 in like 9th grade? Yeah. Okay, so this is a long time ago. You like touch on this in 9th grade. But it means summation. It means you're adding things up. And so we're going to add things up forever. So it would be n equals, and you put, sometimes you'll see 0 there or 1, or it could be n equals 4 or whatever. It's wherever you're starting, whatever nth term you're starting at, forever. And then we write a sub n. So when you go to add this up, it would be a1 plus a2 plus a3 plus ... literally forever. So you're adding up forever and ever. So for example, you could have something like 2 plus 4 plus 6 plus 8 plus forever and ever and ever and ever and ever. Now we're going to talk about, I just made that up with even numbers as something simple. What we're going to talk about in great depth is, does it converge or does it diverge? If it converges, you can get an answer. And that's what totally geeks me out, is you can add up numbers infinitely and get an answer. Because it has this leveling off quality to it, like an asymptote, okay, where you're like headed somewhere. This would diverge because these numbers are just going to keep getting bigger and bigger and bigger, and you're not headed towards any like particular answer. It's just going to keep getting larger and larger. I just made it up as an example. A partial sum means instead of adding up infinitely, you're going to cap it somewhere. Does that make sense? Like instead of going to infinity, we're only going to add the first 10 terms or something like that. It's capital S sub n. It means you're going to add up the first n terms. So you would have a1 plus a2 plus however far you want to go until you get to the nth one. So like if you wanted to add up the first n terms, you would just get the first 10 terms, you would just get the first 10 terms and add them up and get an actual answer. So for example, if you wanted to do 2 plus 4 plus 6 and like cap it there, then you could get an actual answer of 12. Even if the series didn't converge, if you're just doing a partial sum, you could still get an answer because you're not going to infinity, you're capping it somewhere. If the partial sum converges to a finite number, then the infinite series converges to a finite number. We're going to do limits to infinity. That's what like a large part of this is going to be. If the partial sum diverges, like you get infinity or something, then that's not going to work. Okay? So what I want us to do is list out our first few partial sums. Like we're going to do S1, S2, S3, S4. And then we're going to see if we can make a formula for the nth partial sum. That can sometimes be difficult. And so it's good to do a few so that you can get a pattern going. This is very much based on pattern finding. All right. So if we're going to add up the first term, that would just be the first term, right? So just plug in 1 for n. What do you get? 1/2. So that's it. That's your first partial sum. Now for the second one, you're going to have a half plus the second term. To get the second term, you would just plug in 2. So if you plug in 2 for n, what would you get? 4th. So a half plus a 4th would be 3/4. When you add up the first 3 terms, it'll be a half plus a 4th plus, and you're like, why is she writing them all out? Because it's cool. You want to count how many terms you have. Now you would plug in 3. If you plug in 3, it would be an 8th. And then we need to add all those up. Now these two together would be the 3/4 that you had here. So you're adding 3/4 and an 8th. This would be what, 6/8 plus 1/8. So 7. Thank you for heads nodding there, because yeah, fractions, right? I'm only gonna have you do one more and then we'll kind of try to make up the pattern. So this would be a half plus a 4th plus an 8th plus, what would your 4th term be? 16th. Now these 3 added together were the 7/8 that we just got. So what you're doing is you're adding 7/8 and 1/16. This would be 14/16 plus 1/16 would be 15/16. Now what you need to try to do, and this can be very difficult sometimes, is you need to look at the numbers we circled. We have to make up some sort of formula to represent that. And what I'll often do, and there's going to be a fraction in it, so I'm going to put a fraction bar. What I'll often do is off to the side, I'll go, well, when I plug in 1, I should get this. When I plug in 2, I should get this. Like I'll set it up off to the side because it kind of helps me think through it. This one's easier to do the denominator first. So let's look at the denominators. When we plug in 1, we should get 2. When we plug in 2, we should get 4. When we plug in 3, we should get 8. And when we plug in 4, we should get 16. So can you come up with some kind of formula that when you plug in these numbers, you'll get those numbers? It would be 2 to the n. 2 to the first gives you 2. 2 to the second gives you 4. 2 to the third gives you 8. 2 to the fourth gives you 16. So the denominator will be 2 to the n. Now I need a formula for the numerator. We're trying to put this all together. What do you notice about the numerators compared to the denominators? It's 1 less. So how can I write that? Yep, good. 2 to the n minus 1. So you're making up a formula to represent these numbers we circled. Again, that can be hard sometimes. So to tell whether this series converges or diverges, we're going to do the limit to infinity for this. So it's limit as n goes to infinity of this formula that we just came up with. So we have to remember limits to infinity. Let's recap. If the denominator grows super quickly, you end up with 0. If the numerator grows super quickly, you end up with infinity. And if it's a tie, you use your leading coefficients. Do you see how this one's kind of a tie here? They're both 2 to the n. There's nothing written in front of those. So what's really like in front of these? 1. It's like 1 times 2 to the n. So you get 1 over 1, which is 1. So it converges to 1. Can you see how that's kind of making sense? A half, 3/4, 7/8, 15, 16, like how those numbers are getting closer and closer to 1? Okay, so it does logically make sense. Let's try another one. What would your first partial sum be for this series? 1. Good job. Don't overthink it. Your second partial sum will be 1 plus 1. So 2. Because it's literally just 1. Like there's not even an n in it.
Oh, yeah.
Well, a series is adding. Like that's the definition of a series. It means you're adding the lists together. Like that's what sigma means, is you're adding it up. So the third partial sum would be 1 plus 1 plus 1, which is 3. All right, so can we make a formula for that? And again, don't overthink this. This one's a good bit easier.
1 plus n.
Well, just n, like just n. Like it would literally just be n. Because for 1, you got 1, and for 2, you got 2, and for 3, you got 3. So like literally it's just n. So if you do the limit as n goes to infinity of n, what do you get? Infinity. And so we would say it diverges. All right, let's look at this one. First partial sum, you're really just going to plug in 1, okay? So if you plug in 1 here, 1 over 1 is 1. And then if you plug in there, you would have 1/2. So you would get a half. So your second partial sum would be that, what we just did, and write it with the parentheses like I did, because if you just write 1/2, you're not going to like see what I'm trying to show you here. Plus, now we're going to plug in 2. So if you plug in 2 for n, for this series, what would you get? Good, 1/2 minus 1/3. What do you notice happens there? This is what I'm trying to get you to see. If you don't write it all out, you don't see it. If you were to add up this whole list, like what's going to happen then? The halves cancel out. Good. You just have 1 minus 1/3, which would be 2/3. And I'll just show you one more and then we'll make the formula, because I think if we write out one more, we should be good. So you get 1 minus 1/2 plus 1/2 minus 1/3. I know that's a little bit annoying, but write it or you're not going to be able to see what's going on. Now, if you plug in 3 for n, what do you get? 1/3 minus 1/4. And then as you look through that list, the halves cancel and the thirds cancel. So you only end up with the first thing and the last thing, right? 1 minus 1/4, which would be 3/4. So let's see if we can write a formula to represent these numbers we circled. 1/2, 2/3, 3/4. If we plug in 1, we should get this. If we plug in 2, we should get this. If we plug in 3, we should get this. Yep, good. That's really hard to do, in my opinion. I think looking at that pattern and trying to make the formula is hard. And sometimes there's different ways you can write it that mean the same thing. You want to try to go for the simplest thing possible. So off to the side here, we're going to do limit as n goes to infinity of that. And what would you get out of that? 1. Now that is what's called a telescoping series. Do you know what a telescope is? Like you look at the stars, like it folds out, then it can fold back in. It kind of makes sense that it's called that. So a telescoping series looks like this. I'm just going to write it out the way it would be written in a textbook so you can see it. It's B1 minus B2, but then you have plus B2 minus B3 plus B3 minus B4 plus ... Like you add that all up literally forever. Everything cancels out except the first thing and the last thing. So your partial sum is going to be whatever you started with. So like that first term minus the n plus 1th part of that, like the very last thing, which is usually like a tiny little fraction by the time you get out there. So that's what that would, that partial sum would be. And so the whole thing converges if and only if, don't you love that in math class? If and only if, like one of those, do you remember in geometry, you did those things? That was part of the unit where you did like if it is sunny, then I am happy. And if I am not happy, then it is not sunny. I always liked that part of geometry. Anyway, that's what I always think of with if and only if. The limit as n goes to infinity for that last part, the limit as n goes to infinity for this part is finite. So what does the word finite mean? Like if you say something's finite, what does that mean? Like a definite, like a value, basically, like not infinity, basically. Okay. And then your whole sum to the whole thing would be that starting number minus your limit to infinity of that last little part. Most of the time, like nearly all of the time, what do you think this limit is going to go to? Because the time you get out there with that fraction, it's going to be super, super tiny. Like the majority of the time, what do you think this limit's going to go to? 0. And your answer would just be whatever that first number is. Does that make sense? Because by the time you get out there, the numbers will be super, super tiny. I can't even think of an example where it wouldn't be 0. So like it's going to converge to whatever that first part is. I would normally do a break here, but they're going to call you again. So I'm going to just keep going, okay? Then we'll just get done soon. We're gonna do all the notes either way. Okay. It's not like you were gonna get out of doing some of this. Okay. So a geometric series is one of the like special ones that we're gonna look at that follows like a specific pattern. So go ahead and draw your sigma. N equals 0 to infinity. A times r to the n. So this is like one of the special ones that you have to be able to identify. And so when you list that out, it would be a plus ar squared plus ar cubed plus ... forever. A is what you start with, and you just keep multiplying by that r number to generate the pattern. So you just keep multiplying by r to continue the pattern. I don't have a better way to say that. So if the absolute value of r is smaller than 1, then it converges and your sum is a over 1 minus r. So if it converges, you can actually get an answer, and that's your formula to find it. If your absolute value of R is bigger than or equal to 1, I put the equal to on there, but R can't be 1 because if you keep multiplying by 1, like nothing's going to change. Do you get what I'm saying there? Like R won't ever be 1. But anyway, greater than or equal to 1, it's going to diverge. Before I get into the more complicated one, can I make up, like, just can you watch this part? Let me just make up something that's a little bit simpler, okay? Say you have something like, give me a little number. 2, and then we'll say negative a third to the n. First thing you need to do is go, oh, that's geometric. Like, do you see how this is your starting number and then this is R? Like A times R to the n. That's the first thing, is identifying it's geometric. You would say A is 2, R is negative a third. Is it going to converge or is it going to diverge? That's the next question. Converge. You would say it converges because absolute value of R is a third, which is smaller than 1. Your absolute value of this is a third, and that's smaller than 1. Great. Now we can actually get the answer. We said it converges, so we can get the answer. Your sum would be 2 over 1 minus negative a third. And then that would be fun with fractions, and you just have to sort through that. That would give you 2 over what? The negatives would cancel, so 4/3. And when you divide by a fraction, that means you multiply by, okay, we're going to do that a lot in here too. Okay, so it would be times 3/4, and then what would that give you? 6/4. Let me write it down. 6/4 would be 3/2. Okay, you can add up numbers forever and ever and ever and ever forever and get 3/2. It's cool. Cool, guys, get on board. Neat. You can add numbers forever and get an answer. Cool. Let me just show you one more. Give me another number, like just something little.
7.
7, and then say you had 5/2 to the n. First, you have to notice it's geometric. Like, hey, that's geometric. A is 7, R is 5/2. Does it converge or diverge? So you would say diverges because absolute value of R is 5/2, and that is, and then you don't do the problem because you can't. Okay. We're just going to practice a bunch of that. It's just sometimes they don't look geometric right off the bat. And so my suggestion is list out a few of the terms. We're going to start with n being 0. Do you see that there? That's your starting n. Let's plug in 0 and see what we get. We're going to plug in 0, 1, 2, 3, and just generate the pattern a little bit so you can see what's going on. What is anything to the 0 power?
4.
Good. So if you plug in 0 here, this part would be 1. 3 over 1 is 3. You're going to make it. Now, if you plug in 1 for n, what do you get? 3/2. If you plug in 2 for n, 3/4. If you plug in 3 for n, 3, and that's enough. Like if you do the first few and you can get the hang of it, then you're good. Plus ... All right, so we notice it's geometric. What's A? 3. Perfect. What's R? What are you multiplying by each time to generate this pattern? 1/2. Do you guys see that? You're multiplying by 1/2 each time. So does it converge or does it diverge? Good. So we're going to say converges because absolute value of R equals 1/2, which is less than 1. Good. So we can actually get the answer. Cool. It would be S equals 3 over 1 minus 1/2. It's A over 1 minus R. So that would be 3 over 1/2, which would be 3 times 2, good, which would be 6. You can add numbers forever and get 6. Cool. What do you notice I did with this next one? It starts it. So instead of adding up starting here, we're going to add up starting here. So I'm not going to make you write all this over again. if you can figure it out. Instead of adding up 3 plus 3/2 plus 3/4 plus blah, 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 I just took off that first one. So good. It would be 6 minus that 3, so just 3. Whether it converges or diverges is not changed by leaving off the first few terms. And that's the next thing I printed on the paper here. If this converges, so does this. This one starts at 0 and this one starts at 4. You would get a different summation. Like this came out to 6 and this came out to 3. Like, so that would be different. But if one of them converges, the other does too. Does this make sense? Like that's not going to change just by leaving off the first few numbers. All right, let's try a couple more. Do you see that this one's geometric without me having to generate the pattern? Like a times r to the n. Okay, what is a? It's kind of tricky because it's not written. Is 1, good. And what's r? 3/2. Maybe I should have written that out. Do you guys see, like, I need to make you see this. It's 1 times 3/2 to the n. Do you see how this is a? And that's, okay, well, I just wanted to make sure. All right, so does it converge or diverge? Good. We would say diverges because absolute value of r equals 3/2, which is greater than 1. And then you're done. You don't do the problem because you can't. Now, this doesn't look geometric at first glance, so we're going to have to generate a little bit of the pattern, all right? It's starting at n1. So let's plug in 1 for n. What would you get?
8/3.
Good. The negatives cancel. Perfect. 8/3 plus. As a heads up, this one's going to alternate. I still always put plus, and I suggest you do too, just so that you can stay consistent with your list, okay? Now, when you plug in 2 for n, yep, -8/9, and then put another plus. Like just always put plus even if it turns out negative. All right, and then if we plug in 3, you would have -8/-27, which would be +8/27. I think that's good enough. You really only need about 3 terms to figure out what's going on. What is a? It's the first one, guys. 8/3. It's the one you started with. What's r? It's what you're multiplying by to continue the pattern. And sometimes it helps if you just look at the numerators and then just look at the denominators like separately. Good, -1/3. Does it converge or diverge? See if you can write the statement. Converges because converges because why? Perfect. That means we're going to actually do the problem. I know you're like, bummer, right? I know when it diverges, you're kind of just done. It's like, oh, well, it didn't work. That's like the no solution. Remember in Algebra 1 when you get no solution? All right. So S equals A, which we said is 8/3, over 1 minus R, which is -1/3. So that would be 8/3 over what? 4/3. Now, conveniently there, the thirds just cancel. So you just have 8/4. Just, we can add up numbers forever and ever and ever and ever and ever and ever and get 2. If you're exhausted by me being excited about this already, you have a long way to go through Unit 10. It's so cool. It's just neat. All right, we'll do one more of these. So this one doesn't look geometric at first glance. And by the way, ones like this is what the majority of your homework problems are. They don't look geometric at first glance. So you have to kind of generate a little bit of the pattern. It starts with n being 1. So let's plug in 1. If you plug in 1, you would get -2/e². Plus, if you plug in 2, what are you going to get? And sometimes it's cool to look at the numerator and denominator separately. That helps a little bit. Good, 4/e³. And then let's just do one more. If you plug in 3, you would get -8/e⁴. Cool. Just do like at least 3 to see what's going on. So what's A? Good. Negative 2 over e squared. It's whatever the first term is. And then r is what you're multiplying by to keep the pattern going. So again, look at the numerators and denominators separately. What are you multiplying by to keep that going? Yep. Negative 2 over e. Now the absolute value of that would be 2 over e. That's 2 over 2.7-ish. So is that bigger or smaller than 1? Smaller. Okay, so converges because absolute value of r equals 2 over e, which is less than. So we're going to actually work this. This one's going to be a little messy, but it'll be all right. So it'll be a, which is this negative 2 over e squared, over 1 minus negative. Can I write 1 plus? You guys know it's 1 minus, right? But the negatives are going to cancel. You guys are grown up enough to handle that. All right, so 1 plus 2 over e. What you would want to do is add the 1 plus the 2 over e. And in order to add fractions, you need a common denominator. So you need to think in your brain of the 1 as e over e. Does that make sense? E over e would be 1. Here, I'll erase it and write e over e. So if you add those together, what would you get when you put them together? 2 plus e, good, or I'm going to write e plus 2 since that's the order it was in, over e. We put them together. So I have, and I'm going to write it with the flat fraction bars here because that'll make it look a little nicer. Negative 2 over e squared, and we're going to multiply by the reciprocal. So I'm going to flip this over. And there is not a whole lot to be done there. But do you see how there's an e in the numerator and an e squared in the denominator? What can I do with those? Because if this is up here and this is down here, there's like one small thing I can sort of simplify. Whenever you go to add these together, I rewrote the 1 as e over e because I needed to put those together with a common denominator. So again, there's not a whole lot you can do here, but if you have an e in the numerator and an e squared in the denominator, what can you do with like one of the e's? Yeah, like you can cancel out one of them, right? So your final answer would be negative 2 over what? Like if we canceled out one of them, this one's gone. Instead of e squared, what would that be now? Just e and then e plus 2. This last one, this makes me like so happy. And after we do this one, I'll make up another one that you can like see how this works because it's just super cool. If you wanted to know what 0.7 repeating was in fraction form, because it's 0.77777 forever and ever and ever and ever and ever, you can write it as a geometric series. Watch. It would be 0.7 plus 0.07 plus 0.007 plus forever. Are you getting what I'm saying there? Like if you added all these up forever, it would be 0.777777777. It's cool. What is a in that series? 0.7. Now I am going to write it as a fraction so I can get some things to cancel. Do you know what 0.7 is in fraction form? Oh, good. Okay, cool. I didn't have to fight for that one. All right, 7/10. R is what you're multiplying by each time to generate the pattern. So since we just keep on moving the decimal point out one, what are you multiplying by to get from here to here and from here to here? 1/10. Good. 1/10 is smaller than 1. And so your sum is a over 1 minus r. So that would be 7/10 over what? 9/10. What happens to the tenths? 7/9. Oh my gosh, watch this. Look at on the calculator, 7 divided by 9. Hold on, we're gonna do another one. You can make up any repeating decimal you want. It can even be like 2 numbers. Make up one that's 2 numbers, like points. What do you want to do? These are so cool. Love it. 0.38 repeated. What is that as a fraction? I don't know. Let's find out. It would be 0.38 plus 0.0038 plus 0.000038. Do you get what I'm saying there? Forever. So what's A1? Or A, just A. Sorry, not A1. What would that be as a fraction, though? Because we want to get stuff to cancel.
38,100.
It'd be 38/100ths. And what is R? Now, this one we're scooting over 2 decimal points. So instead of a tenth, it's a 100th. That's smaller than 1. How would I set up my sum? Over, that would be 38/100ths over, so 38 over 99. Thank you. I got us there in the end.